So here's the way that a lasso regression can actually make a regression simpler in terms of the number of features that it's using. So what it does is for features that don't help the regression result enough, it can set the coefficient of those features to a very small value, potentially to 0. So imagine that I have up to 4 features that are available to me, x1 through x4, and I don't know which ones are the most powerful. What are the ones that I actually want to be using? I don't want to use all of these if I don't have to. And that m1 through m4 are the coefficients of regression that I get for these features when I actually perform the fit. So in an ordinary multivariate regression, I would get a result that looks something like this. It will use all of the features that I make available to it, and it'll assign to each one a coefficient of regression. What lasso regression will do is it will try adding them in one at a time, and if the new feature doesn't improve the fit enough to outweigh the penalty term of including that feature, then it won't be added. And by not added, it just means that it sets the coefficient to 0. So let's suppose that x1 and x2 are 2 features that are really critical to include in our regression. They really describe the pattern with a lot of power, but that x3 and x4 don't improve the fit by very much. They might improve it by a little bit, but we could just be fitting to noise. Then what will happen is that the coefficients for those 2 features will be set to 0. So m3 will be set to 0 and m4 will be set to 0, which effectively means that these 2 features become irrelevant in the fit. And the only thing that's left is x1 and x2, the original 2 features that we wanted to have anyway. The power of regularization, the power of having this penalty term for the extra features, is that it can automatically do this selection for you.